We just went over how to implicitly derive this with respect to x. This is what it would look like. You would first derive that like regular. You drop the 3, so take 1 away from the power. This would have to be the product rule because x is multiplying to y. So we'll split it up with the 2x and the y. So you take the derivative of 2x, you get 2, and then you multiply it by y plus. You're going to take the derivative of the y, which is 1. Wait, let's write the 2x first. The derivative of y, which is 1. And then you have to go y prime. But, why do you have to do y prime? Okay, then we have plus y squared. No, we drop the 2, so we get 2y. And then you have a 1, so it's 2 minus 1. And then you have to multiply this by y prime, and then you get 0. Okay, implicit differentiation. Implicit differentiation is the chain rule. And yesterday, was it yesterday? Or 2 days ago? I hypothetically gave you guys a definition for y. What if I were to define y? Let's say y equals, I don't know, 5x plus 1. Okay, so I defined y. So technically what I could do, if I didn't like implicit differentiation, I could take this right here and rewrite it, but take out the y's and put in 5x plus 1. Shall we? We shall. Actually, let's put a squared right here too. Okay, so I know I don't want to be boring and stuff. Hey, don't laugh. All right. So times, and then we have, what is that? 5x squared plus 1. And then we have plus, and then 5x squared plus 1. And then square it equals 5. Now we could distribute this to x. We could take care of this power. But I'm not going to. I'm going to leave them there because I'm going to leave it in its purest form so you can see where the y is. So let's take the derivative of this now. We're going to take the derivative of this with respect to x, d over dx. So the 3x squared stays the same, plus, and then we have the product rule here yet again. All right, the derivative of the first function is 2, then we have to multiply it to the second function. And then I have to add to that, what is that? The derivative of that guy times 2x. So I got 2x times, the derivative of that guy would be 10x. Correct? Yes. Okay, that's the end of that one. And then we have this guy right here. What would we do if we don't take care of this 2 right here? What would we have to do in order to get the derivative of that? The chain rule. All right, so I'm running out of space right here, so I'm going to continue on to the next line. Plus 2, I drop the 2, and then I have a 5x squared plus 1. And then I take 1 away from the 2. Right? Okay. And then I have to multiply it times the derivative of the inside, which is 10x equals 0, because the derivative of 5 is 0. Okay. Now, do you see it? Do you know what y prime is? What would y prime be? 10x. Okay. Now look at this guy. That's a y, right? And that's a y prime. That's a y, and that's a y prime. Do you guys see all the y primes? That's y, y prime. That's a y, that's y prime. And if I look over here, I can see the y, the 2y, just right here, 2y, and then 2x y prime, 2x y prime. And then here we have 2y to the first power, 2y to the first power, and then there's your y prime right there. So I'm hoping that that helps you see that y is a function of x. If you're taking the derivative of an equation with respect to x and there's y's inside of there, you have to assume that the y is a function of x. What does that mean? It means this right here. Y equals 5x squared plus 1. I made that up though. Like it could be anything. I just made up 5x squared plus 1. But if we don't know this, this is awesome. Doing this is correct. Okay, if we didn't know the definition of y, that's what implicit differentiation is. Now you also have to get used to writing this a different way though, because it's used, y prime is not commonly used in implicit differentiation. Instead of y prime, we would use, let's write it out. Let's go 3x squared plus 2y plus 2x. Instead of y prime, we're going to write dy. That's the derivative of y with respect to x. dy over dx is the same thing as y prime, plus we have 2y, and then for this y prime, dy over dx. Now, you treat it still the same way. You're going to treat dy over dx like it's a variable, just like you would treat y prime as a variable. This is taking a derivative with respect to x. What you're about to embark upon are problems called related rates. In the related rates world, most of the time you're dealing with time, t. And if you wanted to find the rate of something, we compare it to time, like miles per hour. Hour is time. Does that make sense? Yeah? Okay, so let's write this down again, one more time. We're going to write this problem down, but we're going to take the derivative with respect to t instead. So we have x to the third plus 2xy plus y squared equals 5. Now remember earlier how I said we have to treat y like it's a function of x up here? We have to treat it like it's a function. Now we have to treat x like it's a function of t, and we have to treat y like it's a function of t. So that means we're going to be getting an x prime also. But I'm not going to write x prime. I'm going to write it the Leibniz way, which is it would be dx over dt. So let's get started. All right. You could put x prime. It's just not. It's not as helpful later down the road. That's the best way I can say it. Now, if dx over dt, like writing that is still annoying for you, then yeah, go ahead, write x prime. It's fine. Just later, hopefully you can make that transition. All right, so the derivative of x to the third is going to be 3x squared. But then, since x is a function of t, we must then multiply it by, here, you guys want me to use x prime?
Yeah.
Okay, x prime. Like, I do not want to write dx over dt. So I'm going to write this down on the side. X prime is the same as dx over dt, just so y'all know. Okay, we're taking the derivative of it with respect to t. Now, because we're taking the derivative with respect to t, we have to use the chain rule. For this, we have to use the product rule. So let's do that 2x right there and that y. So we have plus. A derivative of 2x is going to be 2. But then we would take the derivative of x is just 1, and then we have x prime multiplying to that, and the y chilling right there. Then we say plus, and we take the derivative of the y and multiply it times 2x. So let's write the 2x down. And the derivative of y is just going to be 1, but then we have to multiply it by y prime. Alright, so that product rule is done right there. Now let's do this y squared. We drop the 2, we get y, and then we have y prime equals 0. So now the job is to get y prime alone. All right, now don't forget y prime equals dy over dt. So if ever you get a problem that says solve for dy over dt, they're meaning get y prime alone. All right, so let's see. If we're going to solve for y prime, we have to acknowledge which terms have the y prime. This one has a y prime, and this one has a y prime. This guy does not, and neither does that guy, so I don't really care about those guys right now. I have to care about them, I suppose. But let's get rid of these parentheses since they don't really do anything. There's no negative to distribute or anything like that. I'm going to take these two terms, whoops, this guy right here and this guy right here, and I'm going to put them on the other side, which means they're going to turn into negatives. So we have a negative 3x squared x prime plus 2x. What is that? What is that? Oh yeah, 2x prime y. I don't like writing primes. They look like x to the 1 powers.
Yeah, it's minus.
Yeah, thank you. It's supposed to be minus. All right. Okay, and then on this side, on the left side, whoops, I don't want that anymore. On the left side, we're going to have 2x y prime plus 2y y prime. Now, how am I going to get that y prime alone? Talk to your neighbors. All right, so we factor out the y prime. So I'm going to take out these y primes right here and put them on the outside. And now y prime is multiplying to all this. So to get y prime alone, we just must divide. Y prime equals negative 3x squared x prime minus 2x prime y divided by 2x plus 2y, and that's it. Okay, I scribbled that out. So, all right. So this is what we got. Now, this answer is correct. It will work. We will be able to find the slope at any point that's given to us, and the point must be an x and a y. Oh, wait, except we do have a rate right here, which is a problem. Hey, just so you guys know, you see how this is negative 3 and negative 2? If you were to see this in a multiple choice exam, you would not see that. Instead, there would be a negative right here in front. And so these would both be positive. It's almost like these are grouped together and you factor out a negative. All right? It's just another way to manipulate it. It's kind of annoying, but do you guys see that? Yeah. Okay. So make sure you understand that this is the same as this. All right? See, one last thing. These are rates. So every prime variable is a rate. And this equation right here relates all these rates. They're related to each other because they are in the same equation. The equation defines the relationship. So when you hear the word related rates, that's why.